Good morning to all of you. Now we will discuss about equilibrium of forces. Equilibrium of forces. This is mechanics statics portion. This subject is used for engineering mechanics subject for first semester BTech students and also for second semester BTech students. Now we will clearly discuss what is about equilibrium of forces. Okay. Equilibrium forces. If a body is acted upon by a number of forces and if the resultant of the system of force is zero, then the body is set to under equilibrium and the forces are called equilibrium forces. Suppose this is a body. Okay. This body is acted upon by a number of forces. This is a force P, this is a force Q, this is a force S, this is a force P. Suppose this body is acted upon by four forces at point O. If the net resultant is zero, if R is equal to zero, R is equal to zero, then the body is said to be in equilibrium condition. If a body is acted upon by a number of forces and if the resultant of all the forces is zero, that is R is equal to zero, then the body is said to be in equilibrium. And the forces, these are the forces. The forces P, Q, S, T are called equilibrium forces. Equilibrium forces. That means the forces whose resultant is zero, then the forces are called equilibrium forces. And the force which brings the body in equilibrium is called equilibrant. What is equilibrant? Equilibrant means the force which brings the body in equilibrium. The body in equilibrium is called equilibrant. That means the resultant force and equilibrant are equal opposite to each other. Okay, suppose this is force P, this is force Q, this is force S, this is force T. Suppose, okay, this is body. So this body is acted upon by four forces: P, Q, suppose this is P. This point O. How this body is equilibrium? Suppose this is resultant force R. Resultant force R. If another force acting opposite to R, suppose this R dash. This is R dash. R is resultant force, and another force R dash is acting opposite to R, which is equal in magnitude and opposite direction to the resultant force. Then this body is said to be in equilibrium. And this is called equilibrant. R dash is called equilibrant. This is called resultant. This is called resultant. Clear? The body is under the action of four forces P, Q, S, T. Suppose R is the resultant force, then another force acting opposite to R but equal magnitude and same line of action, collinear. Collinear means same line of action. Then this force R dash is called equilibrant, this R is called resultant. So from this figure, it is clear that resultant and equilibrant are equal in magnitude. Okay? Opposite in direction and collinear. And in same line. Clear? R dash R, both are equal in magnitude. Suppose this is 10 Newton. Suppose this is equal to 10 Newton. This is also 10 Newton. This is also 10 Newton. So what is the net resultant force? Now, net resultant. What is net resultant? R minus R dash. So 10 minus 10, 0. Okay. Net resultant force is 0. Now the body is said to be in equilibrium condition. Okay. So what is the condition of equilibrium? Clear? What are conditions of equilibrium? Conditions of equilibrium. Clear? For equilibrium condition, for equilibrium of body, R is equal to 0, resultant R is equal to 0. Clear? What is R? The same place, root over sigma x square plus sigma y square is equal to 0. The same place, sigma x is equal to 0, sigma y is equal to 0. This is condition of equilibrium. This is for concurrent and coplanar forces. Clear? If R is equal to 0, what is R? Root over sigma x square plus sigma square, this is 0. That means sigma x is equal to 0, sigma y is equal to 0. This is condition of equilibrium for concurrent, same point, and coplanar, same plane. Clear? Sigma x is equal to 0. What is sigma x? Last class I have told sigma x means right side force minus left side force equal 0 is equal to 0. This implies right side force is equal to left side force. This is sigma x 0. Sigma y 0. What is sigma y? Upward force minus downward force 0. This implies upward force is equal to downward force. So these are two conditions. Right hand side force is equal to left side force. Upward force is equal to downward force. This is the condition of equilibrium for concurrent and coplanar forces. Clear? What are the principles of equilibrium? Principle of equilibrium. Principle of equilibrium. Number 1, two force equilibrium. Two force equilibrium. This states that if two forces are acting on a body, suppose this is body, this is force P, this is force Q, both acting at point O. Both acting at point O. If two forces are acting on a body and the body is under equilibrium, then each force is equal in magnitude, opposite direction, and collinear. Then if P is equal to 10 Newton, suppose P is equal to 10 Newton, Q is equal to 10 Newton. Clear? What is R is equal to? P minus Q. So 10 minus 10 is equal to 0. Clear? Now, if two forces are acting on a body and the body is in equilibrium, then each force is equal in magnitude, opposite direction, and same line of action with the other force. Clear? That means P and Q are equal in magnitude. Q is equal to P and P is equal to Q. And both are opposite direction and same line of action. This is two force equilibrium. Clear? Next. Three force equilibrium. Three force equilibrium. This states that if three forces are acting on a body, if three forces acting on a body and the body is under equilibrium, then the resultant of any two force is equal and opposite to the third force. Suppose this is force P, this is force Q, this is force R. Clear? three force acting on a body. This is force P, this is force Q, this is force R, this is point O. Then this states that the result of any two force, suppose the result of PQ is equal to R dash. Then another force, third force, this is R. Then R dash is equal to opposite to R. Then body is said to be in equivalent condition. Clear? If three forces are acting on a body and the body is in equilibrium, then the resultant of any two forces is equal and opposite to the third force. Clear? Now PQ are two forces, its resultant is R dash. Suppose R dash is equal to 20 Newton. Clear? And R is a magnitude of 20 Newton. Both are acting same line but opposite direction. Same line but direction is opposite. Magnitude also equal. So what is net force? Now what is net resultant? Net resultant. What is R is equal to net result equal to? R minus R dash. So 10, 20 minus 20. 0. Clear? Now the body is under equilibrium. Clear? Next, for force equilibrium. For force equilibrium. For force equilibrium. This states that if a body is subjected to or acted upon four forces, this is force P, this is force Q, this is force S, this is force T. Clear? Then the resultant of any two force, then the resultant of any two force is equal in magnitude and opposite direction to the resultant of other two forces. Clear? Suppose this is equal to P, this is equal to Q, this is S, this is T. Clear? Then this is point O. So the result of P and Q is equal to R and S and T is equal to R dash. Clear? Suppose this is 30 Newton, this is 30 Newton. The resultant of P and Q is equal to 30 Newton. The resultant of S and T 30 Newton. Then what is net resultant? What is net resultant? R minus R dash. 30 minus 30, 0. Clear? Now net result is 0. Then the body is said to be in equilibrium condition. Okay. This states that if a body is acted or subjected acted upon by four forces, and the body is in equilibrium, and the body is in equilibrium, then the resultant of any two force, any two force is equal in magnitude, and opposite in direction, with the other two forces. Clear? This states that if a body is in equilibrium, if body is acted upon by four forces and the body is in equilibrium, then the resultant of any two force equal opposite means equal in magnitude and opposite in direction with the resultant of other two forces. Okay. Clear? Now I will discuss about Lem's theorem. Clear? Lem's theorem. Lem's theorem. This states that suppose this body, this force P, this force Q, this force R. Clear? This is a body at point O, three forces are acting on the body. Force P, force Q, force R. And suppose this angle alpha, this angle beta, gamma. Angle gamma. Okay? This point O. Clear? This states that if three coplanar and concurrent same plane, same point are acting on a body, and the body is in equilibrium, Clear? If three coplanar concurrent forces are acting on a body, both are coplanar and concurrent, and the body is equilibrium, means the net resultant force is zero, then each force is proportional to each force is proportional to the sine of the angle, sine of the angle between the other two forces, other two forces. Okay, this is Lem's theorem. The theorem states that if three coplanar and concurrent forces, same plane, same point, are acting on a body and the body is in equilibrium, then each force is proportional to the sine of the angle between the other two forces. This is Lem's theorem. I will explain this theorem. Clear? Figure. This is figure. Three force PQ are acting on the body. Let P, Q are three forces. Three forces acting at point O. At point O. Clear? Alpha, beta, gamma is equal to angle between them. As shown figure. As shown figure. Okay. Alpha is the angle between Q and R. Beta is the angle between P and R. Gamma is the angle between P and Q. So, according to Lem's theorem, what is Lem's theorem? P is proportional to sin alpha. This means each force is proportional to sine of the angle between the other two forces. That is, P is proportional to sin alpha. There. This implies P by sin alpha is equal to constant. Equation 1. Similarly, Q is proportional to sin beta. This force Q, this angle beta. Clear? Q is proportional to sin beta. This implies Q by sin beta is equal to constant. Equation 2. Clear? Third force. What is third force? R. What is R? This is R. This is gamma. Gamma is the angle between P and Q. R is the third force. So as per Lem's theorem, each force is proportional to sine of the angle between the other two forces. Clear? Similarly, R is proportional to sine gamma. This implies R by sine gamma is equal to constant. Clear? This is equation 3, this is equation 1, this is equation 2. Clear? Now, we will get a final equation. So, from equation 1 to 3, we will get, clear? QR. Clear? Again I will draw the figure. Clear? This is force P, this is force Q, this is force R, this is point O. Clear? This angle alpha, beta, gamma. We have derived already 3 equations. So combine equation 1, 2, 3. Combining equation 1, 2 and 3. Then what do we get? We will get P by sin alpha is equal to Q by sin beta is equal to R by sin gamma. This is Lem's theorem. Clear? P by sin alpha, Q by sin beta, R by sin gamma. This is Lem's theorem. Clear? Next class, I will do free body diagram. Next class, I will do free body diagram. Clear? The next chapter, next class chapter, and I will do some problems relating equilibrium forces and Lem's theorem, free body diagram. So these are all I will do problems. Clear? Thank you. Please make like, share, subscribe to this chapter. Okay? Thank you.